Hello everyone, I hope you are enjoying your second snow day in a row and your 10th snow day this year. We are going to be reviewing for your tests on Chapter 8 in this screencast, and your tests on Chapter 8 will be on Wednesday of next week. There were 3 students that submitted questions to me via email. This first one comes from FM. FM says, "Hi Mrs. Natero, I was wondering if you could go over number 74 on the graded homework either during school tomorrow or on your screencast. Thanks." Well, FM, let's start by reviewing when we are going to use a one-sample T procedure. If our sample size is less than 15, we cannot use a T procedure if the data are clearly skewed or if there are outliers. We cannot use T. Once again, if our sample size is between 15 and 30, we can use T procedures as long as we don't have outliers or strong skewness. So if there's outliers or strong skewness, we need to make sure that our sample size is at least 30. So let's take a look at question 74. When should we use T? So here are some situations. The first one, we want to estimate the average age at which U.S. presidents have died. So we obtain a list of all U.S. presidents who have died and their ages at death. Well, if I'm doing all U.S. presidents, if I'm finding the age of all U.S. presidents, then I've done a census. There's no need to do an estimate. I actually could calculate the population mean mu. There's no reason we need to do a one sample T interval. So it's not appropriate there. The second question here, how much time do students spend on the internet? We collect data from the 32 members of our AP Statistics class. So 32 is good. Our sample size is larger than 30. However, if we're going to use this interval to estimate the time that all MA students spend on the internet, well, I don't know if AP Statistics students would be representative of all MA students. So yes, we could do a one sample T interval, but I don't know if it would be appropriate to use it to estimate the population mean. And then for this last question, or last part of the question, Judy is interested in the reading level of a medical journal. She records the length of a random sample, that's important, random sample, of 100 words. So our sample size is definitely more than 30. And so even though this distribution is clearly skewed, there's a lot of short words and a few longer words, it's clearly skewed to the right, because she did a random sample of 100 words, that means that her average values, if she did this many, many times, for groups of 100, the average word length would be approximately normal. So here it's okay to use T procedures. I hope that answers that particular question, FM. And now let's move on to 2 questions that were submitted by KC. KC wanted to take a look at question 66 and how we might use technology to find T star. So this question asks us to take a look at a 90% confidence interval. So we're going to focus on this column here. And if our sample size is 77, we know that our degrees of freedom would be 76. And notice 76 is not in the table, so we need to use the next best thing. So we maintain at least a 90% confidence interval. We'd want to use a sample size, or degrees of freedom here, I should say, of 80. So if we didn't have technology available, this is the best we could do. And not all students on the AP test will have graphing calculators, so this would be the expectation that they would use this. However, if you wanted to get a more reliable estimate, or more accurate, I should say, estimate, then we could use our graphing calculator to get the T star value. And here's how we would do that. So we would go to second, distribution, inverse T, and here we need to enter the area to the left. Let me show you what I mean by that. To the left of our cutoff, here we have 90% of our T distribution within these 2 vertical lines here, which means we have 5% in each tail. So the 95% that I'm referencing is based on 0.9 plus 0.05. So we want to enter 0.95 on our calculator, or we could enter 0.05. It would just give us the negative T star value instead of the positive T star value. And our degrees of freedom is our sample size minus 1. So that's 76. Let me show you that you would get the same result if we use 0.05 here. Same result, but the opposite sign, because now we're in the lower part of the distribution where z-scores and t-scores are negative. Let's see how this number compared, the 1.665 number compared to the number in the table. And the number in the table was 1.664 versus 1.665 from the calculator. Pretty close. Pretty close. All right. And the second question that was submitted by Casey was to look at question 68 part B. How would having an outlier affect the confidence interval? And for this one, we're going to go look at Fathom. So this is similar to what I was showing you guys in class with robustness of t procedures, except now instead of my distribution being skewed, it has an outlier, and we can see that one outlier right here. If I inspect my collection, we can see that I have done samples of a sample of size 10 here. I'm collecting 10 values from this collection, which is based on heights, and I guess something was really tall here, maybe it was measured inaccurately, but we have one outlier in the height distribution here, and I'm calculating the mean. Notice the mean of 5.5 matches the mean that's over here as well as our sample size. So I've done some confidence intervals. I've done 100 of them, and 94 of them contain the truth or captured the truth. So that's pretty good. Let's do another set and see if that 95% is pretty accurate, and it looks like it is. So our confidence intervals appear to be doing a good job of capturing the truth. They appear to really be 95% confidence intervals, but let's look at the intervals themselves. Let's look at the intervals themselves. Let's inspect this collection. Try this one more time. Let's inspect this collection. There we go. Alright, so let's take a look at the confidence interval width. Here the width was 1.5, then 2.2. So, oh wait, 5. It looks like the width of the intervals is quite varied. Let's do a graph of the widths of the confidence intervals. Wow, that's kind of weird. Let's think about that a second. I wonder why we're getting this group right here. What would cause us to get this particular set of intervals to be this wide? Well, I'm guessing it has to do with the fact that we have this outlier here. So anytime the interval was created where the outlier was one of the original 10 values, our standard deviation increased drastically, was impacted by that outlier, and that caused our interval to be wider. So this is why there would be a problem with using t procedures with an outlier, and it's not so much because the intervals themselves have a lower capture rate than what we want. It's the fact that we don't know whether our interval included this outlier or not, and if it did, it's going to be a much wider interval. It's going to be a lot less useful than these intervals here. So I hope that answers your question, and I apologize for having a bit of issues with Fathom there. Let's take a look at the very last question. This question was submitted by MS, and MS said, I'm getting really confused deciding whether I need to use Z-star or T-star. Can you clarify this? Excellent question. This is often a case where students get confused about whether to use Z-star or T-star as we're starting to do inference. So let's take a look at when Z procedures are used and when T procedures are used. So Z procedures are used in two cases, either when we're working with proportions or when we're working with means when the population standard deviation is known. And population standard deviations are usually not known. As a matter of fact, if we knew the population standard deviation, we'd probably know the population mean. So really we're only going to use Z procedures if we're working with proportions. And on our calculator, that is called a one-prop Z int. Notice proportion and Z are in the calculator command structure. T procedures are used for inference with means. So Z's with proportions, T's with means. And on the calculator, you'd have a t-interval if you're working with inference on a single mean. I hope this screencast has helped to answer your questions. If you have more questions, please feel free to email them to me. I might actually then send the answer to everyone if I think it would be helpful for everybody in the class to know the answer to that question. And I will see you guys on Tuesday.